Hello judges, the STS theme this year is Decoding the Universe, and my topic is Quantum Science Driving Innovation in Medicine. And this relates to the theme this year, as to understand the universe at its biggest point, you have to understand it at its smallest point. Now, let's get straight into it. First, what is quantum science? Quantum science is the study of the universe at its smallest points. I'm talking atoms, subatomic particles such as neutrons, electrons, and photons, and you get the talk. Now, how can we use quantum science in medicine to create quantum medicine? Well, I'll have to acknowledge that despite the progress in classical medicine, it has limitations that cannot be overcome without the use of quantum medicine. Quantum medicine also focuses on holistic medicine, as it incorporates the patient's physical and mental health in diagnosing and treating a patient. Now, let's move on to some actual innovations. First, diagnostics. First, we have to understand how an MRI machine works. An MRI machine works by manipulating the quantum property of nuclear spin to detect and image the human body. The human nervous system communicates using electrical impulses, which generates very small magnetic fields. Now, we all know about cancer, the nasty genetic disease that causes tumors. Well, these tumors press against tissue, causing interferences within these magnetic fields. This means that doctors can easily see these tumors before they get too serious, allowing for quick treatment and saving many lives. Now, let's move on to how we can use quantum science for treatment plans and optimizing those treatment plans. First, I have to mention what a quantum computer is. A quantum computer is a computer that uses quantum technology such as qubits in order to process information much faster than a classical computer could do. Now, these quantum computers use quantum algorithms, and with these quantum algorithms, we can simulate disease progression, which allows us to figure out where a disease will spread to next. This is useful specifically for treating cancer, as cancer behaves differently with everyone as it is a genetic disease. Now, how can we optimize these treatment plans? Well, in a person's DNA, there are these things called genetic markers, which identify specific traits within a person, such as whether a person is more susceptible to one disease or whether they process information much faster than the average human being. This allows us to specifically give that patient specific medications or tell them to do specific things in order to make sure that they get treated in the best way possible. How can we use quantum computers for research? Well, you see, because quantum computers work at the quantum level, they can simulate chemical interactions much better than classical computers, which means scientists can save time in drug discovery by not having to manually do these chemical interactions. Now, even though quantum technology is very promising, especially in the medical field, I have to acknowledge the limitations that it has, especially that within data privacy, as health records can easily be hacked during the jump from classical computers to quantum computers. Quantum cryptography is another field specifically for that. Not to mention how much quantum computers cost. Because it is a new field, it is very expensive, and only multi-billion-dollar companies have had access to these quantum computers. Now, I would like to acknowledge the poster guidelines this year for STS. First, my poster meets a minimum resolution of 1920 by 1080 pixels, and it is in a PDF format and was created digitally using Canva, with the images being hand drawn, then taking photographs, then being uploaded onto Canva. Thank you for listening to my poster about quantum science driving innovation in medicine.